we have already finished our 14.1, whereby we learned about the first derivative test as well as the second derivative test. Okay, both tests itself, it helps us to identify whether a stationary point is it actually a maximum or minimum. Okay, however, only the first derivative test will actually help us to find out whether it's a point of inflection or not. The second derivative test does not help us to identify point of inflection. So the use of this test will help us answer questions that are related to real-life context. Okay, and today that's what we're going to be looking at. Okay, maxima and minima problems. Right? So let's start off with looking at try 7. I'll give try 6 a skip first. I'll come back to it later. Okay, so looking at try 7. We are asked to find the area of the biggest rectangular garden. Okay, are we ready? Right, that we can make with 36 meters of fencing surrounding the garden itself. Okay, so if I have 36 meters of fencing, there are many ways for us to construct our garden. Okay, so it could actually be maybe of this kind of sizing, okay, or maybe it can be very long and yet just very narrow in terms of its depth, okay, such that it becomes 36 meters itself. So there are many kinds of rectangular sizes that could give us a perimeter of 36 meters. Okay. However, the objective in this question is that we want the area to be the biggest one. Okay, we want the area to be the biggest one. That means that we want to find the maximum area given that the perimeter must be actually 36 meters. Okay, so let's define some variables that we can work with. Okay, so let us maybe define the length to be x. Okay, so we let the length be x and the breadth be y. Okay, and then we talk about the area and perimeter, so we also define the area to be a, perimeter to be p. Okay, I can form an equation for the area using my variables x and y, such that an area of a rectangle will be xy, okay, because length times breadth. And then my perimeter, since it is a rectangle itself, okay, that means 2 times of the length plus 2 times of the breadth. Okay. And we know that in this particular case, 36 meters refers to my perimeter, so 2x plus 2y must be equals to 36 in this case. I could factorize out the 2 so that I know x plus y must add together to give me 18. Okay. So I want my area to be the biggest, that means my area, I want it to be maximum. Okay, so if I want area itself to be maximum, that also, you can imagine it as though it is a maximum point, okay, in a curve itself. Okay, so your maximum point need not always be talking about curve. In fact, any given function you can plot out a curve. So if I want A to be actually a maximum, according to my second derivative test, okay, what is this area going to be? So, before I can find out what is the second derivative, okay, which is differentiated with respect to x, right? Okay, but down here is xy, so I need to actually change this equation such that y is in terms of x, and I rely on this part over here. So, y is equals to 18 minus x. Okay, so that I can say that a is equals to x times 18 minus x. In other words, we want to simplify it. A equals to 18x minus x squared. Okay. So because we are looking for a maximum point that is actually a stationary value, your first derivative must be equals to 0 in the first place. So dA over dx, sorry, I forgot to find dA over dx. Okay, so we find dA over dx first. So we have 18 minus 2x to be equals to 0. And x will be equals to 9. Okay? So we get a stationary value when x is equals to 9. That means your length is equals to 9 itself. Okay? But then, I only know at this juncture that x equals to 9 gives me a stationary value. I do not know yet that it is going to be maximum. So I must go and verify that it is going to be a maximum value itself. That means my area is going to be maximum. Okay, you cannot rely on the assumption that since I only got one value, confirm that one must be maximum. By right, it should be lah, because the question already specified it. Okay, but you must actually go about proving that it is going to be maximum. Okay, so finding the second derivative. We find that it will be equals to negative 2, and that is less than 0. So we say that A is maximum when x equals to 9. Okay. And then therefore, to find out the area, because question wants us to find area, A equals to x, y, which is x, 18x minus x squared. We would get 81 meters squared. Any questions? Sorry, let me change my marker. In the meantime, you think about it, okay, whether you have any questions. You're good? Okay, so let's move on to look at try 8, alright? we're given a triangle with a rectangle inscribed in it. Okay, so in the rectangle itself, we are given that the length is x cm and then the breadth is y cm. For the right angle triangle, we know that the side over here is 5 cm and this is 12 cm. Okay, the question wants us to show that the area of the rectangle can follow this equation over here. Okay, so the rectangle referring to is this one. Okay, so how do we actually form this equation for the area, okay, of this rectangle? Right? Since we know that the length is x and the breadth is y, it definitely, okay, we are able to say that A is equals to xy. Okay, so that's the very first step that we are able to state. Right? But then, okay, given in the question, we want it all in terms of x, so we need to convert the y into x itself. Okay, so looking at this question, how can we actually change the y in terms of x? So that is the challenge. Okay, any ideas? How do we change y in terms of x? Ideas? Any? What do you think? Try any idea pop up. We are given a triangle. What do you think about when we have triangles? Or anybody else in the class? We're given triangles, what will you think about? No idea. We do a lot of triangle related stuff, right? Similar triangles. Okay. I hope that you're not thinking about Pythagoras theorem. Okay. Well, it is not wrong to think about Pythagoras theorem. Okay. But it isn't helpful, okay, for us, right? Because we're looking for this y and I want to change it in terms of x. Okay. So we look for similar triangles. Okay. In this case, we have a few similar triangles. Right. One straightforward one that we could consider is this one over here. Okay, bring out in blue, and then the other one that is the bigger one. Okay, so they are similar because, okay, we know that this part will actually be 90 degrees as well. Since it is a rectangle, down here confirm 90, it's a straight line, so down here 90. Okay, so these two angles are actually equal and they share a common angle over here. Okay, you need not actually prove it, but you need to at least know, okay, so that you can justify for it. You cannot anyhow just based on its appearance think that they are similar. Okay, so therefore, okay, we recognize that the blue smaller triangle here is similar to the larger triangle. Why do I choose these two triangles? Because I want to change my y in terms of x. So I want to have a triangle whereby y is inside it. Okay, so that's why I choose this triangle over here. Okay, so looking at these two similar triangles, I form my equation. Whereby the corresponding sides y, okay, corresponds to this AB, which is 5, and my FC over here corresponds to the longer length 12. Okay, and I know that FC is actually 12 minus x. So I can see that y over 5 is equals to 12 minus x over 12. Okay, and then I just have to bring this over 5 to the other side such that I have y equals to 12 minus x over 12 times 5. Okay, then I substitute this into my original area. Okay, since y is now 12 minus x over 12 times 5. Okay, so we just have to do a little bit of manipulation such that we get the form that we are asked to actually achieve. So I just have to shift the denominator over to the 5 instead. Okay, and then we have shown it. maybe before we go into part 2, I just want to also explain why is it that the area, okay, is bounded by x values that are between 0 to 12. The reason it is being bounded from 0 to 12 is because, okay, my x actually is this length over here. Okay, so it sits in the triangle whereby the base over here, right? Okay, the maximum that it can go to is 12. Okay, the least that it can go to is 0, whereby the triangle doesn't exist at all. Okay, so that's why your length x can only be ranging from 0, whereby it's all goes up, okay, all the way to 12, because that's the size of the triangle that we're given. Okay, so that's why they give this kind of inequality. Okay, but we need not actually go about stating this inequality. Our objective is to show that A in terms of x will be expressed this way. Okay, so imagine all the way here. Right? Looking at part 2, we want to calculate the value of x for which A has a stationary value and show that this value of x, okay, actually makes A to be the maximum. So likewise, okay, as per previously, we want, okay, A to actually be maximum. So A is also a stationary value. So we can find the first derivative to allow us to find out what is the value of x. Okay, then after that we use the second derivative test to prove that it makes A to become maximum. Okay, would I give you about 5 minutes to give this a try on your own? Alright, similar steps to your try 7 earlier on. If you have no idea, please raise your hand, I'll come to you. Okay. little bit more time. Some of you only just started appreciating. X should be equal to 6. And second derivative test should be good enough for you to actually prove that A is maximum. Variation in the way you want to do your differentiation. Some of us prefer to do product rule, which you can. Okay, and if you want to do product rule, this is the term on the left, this is the term on the right. Okay, then you apply accordingly. Upon simplification, you should get -5/6x plus 5. Okay, some of you don't like to do product rule, you want to expand it and then simplify from there. That's perfectly fine as well. Okay, your answer should actually be the same. Then because you're looking for the value of x such that A is a stationary value, that means that our dA over dx must be equals to 0. So x will actually give us 6. Okay, so when x equals to 6, A is a stationary value. Okay, and then because the question asks, okay, show that this x equals to 6 gives us, okay, a maximum. But upon doing our second derivative test, we already get -5/6. That is less than 0, and therefore A is maximum when x equals to 6. I need not go and find out what is the maximum the maximum area itself. Okay, but if you really want to go and find out what is this maximum area of the rectangle, okay, that it could get, you could actually find that out by taking x equals to 6 and placing it inside the formula for x. Okay, so we would be able to get this 636 divided by 12 to make 15. Correct? 636 divided by 12 is 6. Sorry, 36 divided by 12 is 3. Yes, so the maximum area will actually be 15 cm squared if that is what the question wants you to find. Okay, so by doing this process, it helps you to find out, okay, what is that length, okay, that will give rise to their maximum area. Alright? Questions? Okay, let's take a look at try 9. Try 9 is something different slightly, okay? x. So the question asks to find the coordinates of the point on this particular curve y equals to square root x that is a minimum distance from 9, 0. Okay. The shape of y equals to square root x is something like this. Okay. So what the question is asking is that there is this point 90. Okay, so 90 is found on the x-axis because your y coordinate is 0. So let's say it is this point here. Okay, I want to know what is the coordinate of one point, okay, that is found on the curve such that this distance is actually the minimum one. Okay, so that's what the question is asking. Okay, in case you're wondering, right, why the shape of the curve is this way, y equals to square root x is of this shape. It is not part of our A-Math syllabus now to be talking about parabolas. Okay, previously in our previous syllabus, we do talk about curves of this shape for square root x now. But maybe, okay, for your understanding also, okay, how I actually come to this shape itself, we think about y equals to square root x as the same thing as y squared equals to x. Okay, we know the shape of y equals to x squared. Right, these are two different things. We know the shape of y equals x squared, right? Okay, and y equals x squared is a simple quadratic curve that's like that. Okay, right? But now we're looking at y squared equals to x. Okay, so it's like the axis itself is reversed. Agree? Okay, so but yet you still label this as x, this as y. Okay, but yet it's now reversed. Alright? So y squared equals to x actually has a reverse shape. Okay, you're just turning the axis around. Okay, so y squared equals to x is of this shape. But because we're thinking of y equals to positive square root of x, okay, that means that for any x value that we have, y is a positive value because this is a positive square root sign. We're only looking at this part of the ground itself. Okay, that's why I get this shape. Right? So I'm just sharing with you, okay, why I get this shape. You don't need to go and bother yourself, okay, with learning the shape of this graph because not part of our syllabus anymore. Okay, but then, so I think that to improve this question, okay, what the textbook would have done is to give you the diagram. Okay, by right, if they give you such a function, they should have given you the diagram. Okay, might be an oversight from the publisher itself. But I think that it is a simple understanding for us to grasp as well. Okay, it's just a changing of the orientation to the other way around. Okay, so looking at this question, back to this question, we want to find out what is this minimum distance. Okay, we want to know we don't want to find minimum distance, we want to find the coordinates that give rise to a minimum distance. Okay, so this coordinate, because it is found on the curve, that means that, okay, if my x coordinate were to be x itself, that means that my y coordinate based on the equation needs to be square root x. Okay, because when x is equals to x, your y must be equals to square root x. Okay, so that is the coordinate of that particular point in a generic sense. Okay, we want to find that coordinate that gives rise to a minimum distance. So let's define the variable. Okay, we let the distance between the point on the curve to 90 be the variable d. And let the point be x Okay, the distance that we're looking at is a straight line distance. So D itself, okay, for this straight line distance, if I know this coordinate and I know this coordinate, okay, we go all the way back to how we learn our length of line segment. So we recall the formula of length of line segment. Okay, we're given 2 points. The difference in the x coordinate squared plus the difference in the y coordinate when you square it, that gives us the length of line segment. So in this particular case, this value d over here would actually be 9 minus x squared plus 0 minus square root x squared. Okay. We work on simplifying this expression. So 0 minus square root x square again will give us a positive x. We expand the 9 minus x square. So our distance d has this expression of square root x squared minus 17x plus 81. Okay. We want this distance to be a minimum, so I find the stationary point first. Okay, so maybe I shouldn't have chosen the method now that I think about it. Never mind, we shall do dd over dx. Okay, so we're differentiating this up. So to help us, let me re-express it into power of half. So bring down the power. Okay, upon differentiation, our first derivative will be this. Let me simplify it to something neater. And we get this. Okay. So our first derivative must be equals to 0 to give rise to a stationary point, okay, or stationary value. So we let our dd over dx equals to 0. In other words, my 2x minus 17 should be equals to 0. So x equals to 17 over 2. That would actually be 8.5. Okay, so at this juncture with 8.5, it only tells me that, okay, that at 8x equals to 8.5, my distance is a stationary value. I have not yet proven that it is a minimum value. So I need to go on to use second derivative test or first derivative test, okay, to actually figure out and show that when x equals to 8.5, I will be getting a minimum value. Okay. Now, okay, this is the part where I want us to realize, okay, how challenging it could be if I want to differentiate this another one more time. Do we agree that it's going to be challenging? It looks complicated enough, right? Okay, so that's why other than learning our second derivative test, we need to also learn your first derivative test. Okay, if you yourself find that this, okay, is going to pose you a problem in differentiating one more time, then I would suggest go and do your first derivative test. Because first derivative test is where I just take x equals to 8.5, put inside this, okay, then I put minus 0.1, put inside here, plus 0.1, put inside here. That one is a calculator pressing skill. Okay, then definitely much easier for all of us, rather than going into the algebraically challenging part in differentiating this a bit. Okay, so I'll show it both to you. I'll show the differentiation first. Okay, so in this case, I shall use quotient rule. Wait up. Okay, quotient rule. D over dx squared. So I will keep the bottom, differentiate the top, minus away, keep the top, differentiate the bottom, actually at this juncture I feel like giving up. I don't know how you feel, but I find it challenging as well. Wait keep bottom, differentiate top, keep the top, differentiate the bottom, power half minus 1 negative half, still need to differentiate the inside. Okay, if you use quotient rule, this will be how it looks like lah. Okay, not trying to scare you, alright? But I really want to show you that it is going to be challenging and difficult. Okay, that's why I will urge you in this case to do your first derivative test rather than to do second derivative. Okay, I hope I didn't make any mistake over here. Okay, I kept the top here, differentiating the bottom, this part. I need to keep this 2, bring down power half. This entire thing power minus 1, this one negative half. Then I must remember to differentiate the inside, which is 2x minus 17. Okay? Alright? So you have to go through all of this in order for you to say when x equals to 8.5, sub in inside. Okay? Sub this value inside here. I wouldn't bother to simplify, I'll just press calculator already. Okay, it will get you 2.96. Okay, wait. Sorry, no. 0.33806. And that is positive. This is if you want to use your second derivative test. Okay, if we use our first derivative test, definitely much easier. This case dd over dx, and then the sketch. So we have 8.5. Okay, and I will have this. Right? Sorry, minimum. Sorry, my bad. We should get this table lah, because the question already say minimum we surely should be getting this lah. Okay, so therefore we say that we need to find the coordinates, so we need to find the y coordinates still. So square root x equals to square root 8.5. That is equals to 2.96, or if you want to leave it in third form, 16, 17. square root 17 over 2. Okay? Yes. Yes, go. Yes, Renee.
So that's the same.
We don't have to find the minimum minimum distance because they're asking for coordinate only.
Yeah. Yeah. Because the question only asks to find coordinates, but never asks for minimum distance value. Yeah. But you can, okay, if you want. If the question asks you, okay, I'm sure you're competent in doing that. Just take the x value, substitute inside here. Okay, and then you get the distance. Okay. Questions? Right, so we need to be flexible. Okay, don't always stick to using second derivative test. Also be open to doing first derivative test. Okay? Yes. This is a fraction. It's not about shifting, but about seeing that x minus Any other questions? Okay. Yes, Susie.
So I don't understand why the
Why the y-axis? Y coordinate you mean?
I mean x coordinate.
The y coordinate is square root x. It's because your function is y equals to square root x one. So if your x value, okay, let's say if your x value down here is 2, then you put inside the function here, your y coordinate must be square root 2, right? Correct? Then if it is 3, then your y coordinate must be square root 3. Based on this. Right? So that's why the y coordinate must obey the function over here. Y coordinate must be equals to square root x. Understand? You agree, right? 3 and then square root 3, 4 and then square root 4, 5 square root 5. So x square root x, it's not just about y equals square root x. I give you any function also the same way. Okay, y equals to x squared. If I give you an x coordinate over here, let's say it's 2, what does it plot towards 2? It will become 2 squared, so down here must be 4, right? If down here is 5, then down here must be 5 squared, is 25. So for any point on the curve, the coordinates must fulfill x and x squared. Must have that pattern. That's how your function works. Okay? Any questions? Other questions? Okay, just